Hi, welcome to the fifth video in the series AWS Solution Architect Certification. In this video, we are going to focus on data analytics and storage. Okay, let's look at the first question. The first question, a leading manufacturing company needs to develop a real-time alerting system for predictive maintenance. The manufacturing equipment is generating a large amount of sensor data that needs to be ingested and then persisted as per the regulatory requirements. The team runs analytics on top of this data to generate real-time alerts. Okay, so what are the key requirements? So it's generating a lot of large amount of sensor data that needs to be ingested and then persisted as per the regulatory requirement. Then the team will run analytics on top of this generated data. The alerts need to be real-time alerts. Okay, so there are three things. One, we need to ingest the data, persist the data, and then run analytics so get real-time alerts. Okay, now let's look at what are the options we have. The first one is the Kinesis data firehouse can ingest the streaming data into S3 and then analytics can be run on S3 using Athena. So Kinesis data firehose, first of all, it cannot ingest the data. It's more like an ETL framework. It will extract, transform, and then load it into S3 or any other source, but it cannot ingest the data. So this is not a correct option. Now let's look at the second one. The Kinesis data stream can ingest and persist the data in real time, and then analysis can be performed on the data to generate real-time alerts or dashboard using compute services such as AWS Lambda, EC2, and Kinesis data analytics. Okay, so now we know that Kinesis data stream can ingest the data. So this is correct, and then it can also persist the data in real time. It's a real-time service compared to data firehose, which is near real time. Okay, and then once you persist the data, then you can run either AWS Lambda or Kinesis data analytics on top of that to generate real-time alerts. So this seems like a very good fit for the requirements that we had. Now let's take a look at the third one. The data can be ingested to SQS queue service, which can have AWS Lambda as the consumer. AWS Lambda will perform the requisite analytics to generate alerts. Yeah, AWS Lambda can perform the analytics, but SQS service is not really, it's a queue service, not really ingest a large amount of data from sensors, etc. So that's not the use case for SQS. So this is definitely not correct. Let's look at that last one. AWS data analytics service can ingest the data and persist in S3. AWS Athena can be used to run the ad hoc queries to generate real-time alerts. So data analytics service cannot ingest the data and persist the data. Neither can it extract and transform and then load it to S3. So this is not a correct answer. So the only right fit we have for this question is number 2. Okay, great. Now let's look at the second question. A leading automobile company needs to perform ad hoc analysis on point of sales data generated across the country. Once the data is extracted, it needs to be transformed and stored durably, where ad hoc analysis can be carried out on a need basis. The AWS architect has been tasked with designing a cost-effective solution on AWS. Okay, so the AWS architect needs to design a cost-effective solution. So we have to look at cost effectiveness. Then the second thing is the data needs to be extracted. The point of sale data needs to be extracted, transformed, and stored durably, where you can perform the ad hoc analysis. So there are 4 things we need. We need the data to be extracted, transformed, and then stored. Then the second one is you need to be able to perform the ad hoc analysis. And third one is it should be cost effective. Okay, now let's take a look at the possible options. The Kinesis data firehouse can extract the Lambda function, does the transformation, and then it can be stored in S3. Athena can perform the ad hoc analysis. So this seems like a very good option. This is what Kinesis data firehouse does. It extracts the data, transforms it using the Lambda function, and then it can store it in the S3. So this is a perfect use case for data firehouse. Then for ad hoc analysis, you can use AWS Athena, which is a serverless solution. So this looks like a very, very good solution which meets all the options. And let's take a look at the other options that we have. The Kinesis data stream can ingest and persist the data in real time. That's true. Then this data can be used by Kinesis Firehose to extract and load the data to S3. And AWS Athena can perform the ad hoc analysis when required. So this is very similar to the first one. The only thing is that you are additionally using Kinesis data stream to ingest and persist the data, which might lead to additional cost. So and we are looking at a cost effective solution. So this is a good, this is a possible solution which will meet all the requirement, but not a cost-effective one. So we'll rule this out. Okay, let's look at the third option. The Kinesis data firehose can extract the Lambda function, does the transformation, and then it can be stored in AWS Redshift. Queries can be run on Redshift to generate the reports. Yeah, so Kinesis data firehose can extract, then you can do the transformation using Lambda function, and then you can store it in AWS Redshift. But when when you need to do the ad hoc analysis, mainly it's recommended to use the Kinesis. But if you are doing a lot of reportings, then you can use Redshift. So it's mainly used for when you have standard complex queries that need to be run, you use a Redshift. But if it's ad hoc analysis, then you just use the Athena. So that's why it's not a cost-effective solution. So we'll rule that out. Finally, the Kinesis data stream can ingest and process the data in real time. The data can then be used by Kinesis Firehose to extract and load data to S3. AWS QuickSight can perform the ad hoc analysis when required. So yeah, you can. It's similar to 2. You can use the data stream to ingest, and then you can use the Firehose to extract and load to S3. AWS QuickSight, it does not do it does not perform the ad hoc analysis. It's more a visualization tool like Power BI. So this is ruled out. So the correct answer for this is the first one. Okay. Now let's take a look at the second one. The third question. A leading retail company is concerned about increasing in-house storage costs. It wants to use AWS as a hybrid storage option. AWS Architect has been assigned the task of exploring the hybrid storage option for Windows file share with 100 TB. So what are the key requirements? You have a Windows file share with 100 TB. They want to explore the hybrid storage option. Now let's see what are the options that we have. So using the first one is using the tape gateway with S3 Glacier as cloud storage can be an effective hybrid storage for storing file share data. Okay, so yeah, that's a possibility, but the tape gateway is not used for file share storage in S3. So this is not a correct option. AWS Volume Gateway utilizes IC protocol to store data in S3 and can be used as a backup option for storing the file share data. Again, so the AWS Volume Gateway utilize the ICA protocol, but it is not used for the Windows file share data. So this again you can rule that out. File gateway enables you to store. Okay, the file gateway enables you to store the file data as objects in Amazon S3 and uses SMB NFS protocol. It can cache the frequently used data to reduce the latency. So that's true. The file gateway can enable you to store the file data as objects in S3, and it uses the SMB NFS protocol to access the data, and it can also have the cache that can be used for the frequently used data to reduce the latency. So this seems like a very good option. Finally, data sync can be used to copy the on-prem from so the data sync can be used to copy the data from on-premise file share to AWS S3. Yeah, that's correct, but it doesn't serve as a hybrid storage option. So this one is ruled out. So this one is the correct option. Okay, now let's look at the final question, question 4. A leading manufacturing company runs its analytics suite using in the US East 1 region. Its customers across the globe can upload the images of the defective equipments in the S3 bucket in the US East region, which then triggers the S3 event notification to the compute service to analyze the image and generate the potential issue finding. So basically you upload the images in the S3 bucket in the US East region, and then the S3 event notification triggers the compute service to analyze the images. The number of concurrent uploads varies maximum between 20 to 30 per hour, and at times there are no uploads for days. What is the most cost-effective compute solution for this event-driven application? So it's an event-driven application. We need to look at what is the most cost-effective compute service that can help in this case. So there are sometimes there are at max about 20 to 30 uploads per hour, and for some days there are no uploads. So let's look at the options that we have and see which is the most cost-effective one. Run the compute logic in AWS Fargate launch type container to enable scalability and cost effectiveness for analyzing the images. Okay, so one option we have is use the AWS container service with Fargate launch time, which is serverless. So that's one option that you have. But the problem with this is it's a event driven. So when it's event driven, that means you don't need to run it continuously. Mostly, there will be an event that would trigger the need to have a compute service, right? But AWS ECS container is going to run continuously. So it's an option, but it's not the most effective one. So let's look at the other option and then we can decide. Second, use EC2 instance to run the compute service, which will analyze the image on a periodic basis to generate the findings. So again, this is going to be even more expensive. It will run continuously. So yeah, this doesn't seem to be a very good option. The first one is better than the second one. So we'll rule out the second one. Run the compute logic in AWS EC2 launch type container to enable scalability and cost effectiveness for analyzing the images. So again, this is very similar to the first one. Use the containers with EC2 launch type. Again, there is going to be some management overhead and it might not be a very cost effective solution. So let's finally look at the fourth one, again because it's an event driven application, right? Use the AWS Lambda function as compute service, which will be triggered by S3 event notification on upload of image to generate the findings. So yeah, I mean, this seems to be the most appropriate one because there are days when there is no upload happens and you need a service that runs only when it is required. So every time every time there's an upload, the Lambda function can be executed and it can run and generate the findings. So this seems to be the most cost-effective solution. So the fourth is the correct answer. That's pretty much it from this video. Thank you very much.